here, the integration of x e to the power negative 2x in number 1. Integration of x e to the power negative 2x. First, we assume that this is. Now, first, you have to ask yourself, which is easier to you to integrate, x or e to the power x?
X.
Which one, grade 11?
X, teacher.
Grade X.
X. Yes. So this is u, and this is dv. So if u is x, so we need to find du, which is 1 dx. And if e to the power negative 2x is dv, so v will be the integration. Now, what's the integration of, as you remember before, e to the power u? What's the integration of it?
E to the power u plus c.
No, okay, but here, what do you have to do? E to the power u times du will be the integration of e, e to the power u plus c. I mean here, you have to say it's e. Yeah, the answer will be, after you solve it, e to the power negative 2x over negative 2. Let's remember why first. And we said that to solve it here, e to the power negative 2x, we assume that is u. So if u is negative 2x, du will be negative 2 dx. Then after that here, so it will be e to the power u times du. What is du? It's negative 2. No, sorry. Du, it's e to the power negative 2x. We assume that this is u. So we say then, if u is negative 2x, so du will be negative 2 times 1 dx. The integration here is integration of e negative 2x times dx. So it will be the integration of e. And instead of writing negative 2x, we have to write u. And instead of writing dx, it will be du over negative 2 from here. So dx will be du over negative 2. Then the integration will be negative 1 over 2 e to the power negative 2x plus c. This is here the answer. So the integration of e to the power negative 2x will be negative half e to the power negative 2x. So we used our information in chapter 6 in order to find here the derivative of e to the power so v will be negative half e to the power negative 2x. So after now, we found u, du, dv, and v. Let's come back now to our integration. So the integration of u dv is u times v. Where is u? Times v. So x times negative half e to the power negative 2x minus the integration of v, which is negative half e to the power negative 2x times du, which is 1. I'll repeat, the formula was the integration of u dv will be u times v minus the integration of v du. Then
Teacher, مش du is equal dx.
1 dx, yes. So then now, let's simplify it now as negative half x e to the power negative 2x plus half the integration of e to the power negative 2x dx. Then after that here, the first part is found now, but the second part here, we have half e to the power negative 2x. This part here, we need now to integrate it. So then we need to find now the integration of e to the power negative 2x dx, as I did before. Let's remember that if you need to find the integration of e to the power u, we have to say that this is u. So if u is negative 2x, we need to find du, which will be negative 2 dx. So dx will be du over negative 2. Then, so we found e, or we substitute e as e to the power negative 2x as e to the power u. Instead of u, you have to write e to the power negative 2x. And now instead of dx, you have to write du over negative 2. So it comes like negative 1 over 2, the integration of e to the power u du. And we know before that the integration of e to the power u will be e to the power u plus c. So the answer will be negative half e to the power negative 2x plus c. So negative half x e to the power negative 2x plus half. Now, the integration of e to the power negative 2x, which we found it here, let's write it here as negative half e to the power negative 2x. Now we finished. There's nothing we need to integrate it. So now the final answer will be negative half x e to the power negative 2x minus 1 over 4 e to the power negative 2x. That's it. Look at it now. Did you find it clear?
Yes, teacher.
Yes, teacher. Teacher,
Yes.
is there something called second integral, like second derivation?
Second integral, it's like this. But so when did you see it? Where did you see it?
No, I'm just asking.
Ah, yes, there's a second integral, and there's a third, but this one you take, يعني, will be in second or third year in the university. And there's an, yes, this is an integral, this is and there's something we call it partial derivative. This will be the second derivative and then partial. Well, there's a type of integration like this, but this is used in electrical engineering. We will not use it here. But yes, there's a second and there's a third integration.
Okay, thank you.
Yeah. Is it clear?
Yes, teacher.
Right. Let's solve now number 2. In number 2 here, we need to find the integration of x times e to the power 3x dx. So this is u and this is dv. So let's say if x is u, so dx, oh no, just like this, sorry. So the first step, we said if x, let's say that u is x. So for u, we need to find its derivative, which is 1 dx. And for e to the power 3x dx, we assume that this is dv. So we need now to find v. To find v, we need to integrate e to the power 3x. So now, on this one, we cannot find it quickly. We need now to go to lesson number 3 to go to U-Substitution in order to find e to the power 3x. Let's now do it here. The integration of e to the power 3x dx. Solve it. First, we assume that this is u. So we say that if u is 3x, so du will be 3 dx. And then, so du over 3 will be dx. Now here, e to the power u times dx. Now we say that dx is du over 3. So now we have it as e to the power u times du over 3. And we know before that the integration of e to the power u is e to the power u plus c. So now we have it as 1 over 3 e to the power u, or 1 over 3 e to the power 3x. So now the integration now of v will be third e to the power 3x. By now, is it clear?
Yes, teacher.
That's on 3. I think most of you know it. Here, how to find the integration of e to the power x. After we find e, du, dv, and v, let's come back now to our integration. U times dv will be u times v. U times v, which is x times third e to the power 3x. U times v minus the integration of v du, which is 1. So then, so will be 1 over 3 x e to the power 3x minus 1 over 3 integration of e to the power 3x dx. Now, so here the first part is already integrated. But we need now to integrate the second part. The second part here of e to the power 3x, we already found its derivative here. So we will use it. We write, instead of integration of e to the power 3x, we write, I will write this one. Third e to the power 3x plus c. Now there's nothing to integrate, so this will be now our final answer. 1 over 3x to the power e, x e to the power 3x minus 1 over 9 e to the power 3x plus c. Is it clear?
Teacher,
Yes.
Teacher.
from where we get minus 1 over 3?
This one?
No, the down.
Here.
The pink.
Ah, the pink. Okay. This 1 over 3, I put it up. Yeah, I put it here outside.
Yeah.
Then I will integrate next time.
Why we have 2 1 over 3?
First time, we integrate e to the power 3x. And its integration is 1 over 3 e to the power 3x. So the first one, this one here, 1 over 3 e to the power 3x, I integrate it as 1 over 3 times e to the power 3x. But from the formula, which we say that it is negative or minus the integration of v. So I need now to reintegrate e to the power 3x. I need now to integrate it in the next time here. Oh, another time, I mean. Yeah. So then 1 over 3, then the integration of e to the power 3x, which is third e to the power 3x.
Okay, thank you, teacher.
You are welcome. Now I will post an example and homework for you. Number 3. I need now from you to solve it on the discussion room.